Okay, so it looks like I accidentally managed to disconnect the recording of the first part of this video from the second part of this video. So I'm redoing the second part of this this class discussion without the class. So anyway, we left off by talking about this idea that it should make sense that when the ratio of the length of the opposite side to the length of the adjacent side is a certain value, we can measure that angle that corresponds to this ratio and that value, write that value down somewhere in a reference book, or we can write down the angles that correspond to all of the possible ratios of the opposite side to the adjacent side, right? We've got the opposite side and the adjacent side here. So whatever that ratio is, and we can write down the corresponding angles. So whether it's this angle or this angle, whatever it is, we can write those ratios down, or we can let a calculator calculate them. And we're going to call this the tangent. It's going to be very annoying to keep saying the ratio of the length of the opposite side to the length of the adjacent side. We don't want to keep doing that. So we're just going to call it the tangent. Okay? Now, we have some other sides of the triangle too, and we're going to do the same thing with those. We have the ratio of the length of the opposite side to the hypotenuse, or we have the ratio of the length of the adjacent side to the hypotenuse, and we're going to give these ratios names as well. So we're going to call the opposite over the hypotenuse the sine. We're going to call the adjacent over the hypotenuse the cosine. And again, we've already talked about the tangent. So what we say then is that these ratios are called trig functions, and this is short for trigonometry, the measurement of trigs, okay, or trigons. Point is that in a right triangle, and this is where that comes from, right? Triangle, trigonometry. The point is, in a right triangle, for a given number of degrees for an angle theta, these ratios of the lengths of sides will always be the same no matter what the actual values of the lengths of the sides are. And we have reference books that tell us what these ratios will be for any number of degrees. Or if we have the ratio, we can find out what the corresponding number of degrees must be. So to help us learn more about this, we're going to use an old-fashioned way of doing things. This is what I had to do when I was in high school. We didn't have calculators. We didn't have computers to help us out. We had to go to a book to figure this out. And so I've given you this link here, and this will take you to a page that shows a trig table. And this is the reference that I'm talking about here. Okay, this is the trig table. And for a certain number of degrees, it tells you what the sine and the cosine and the tangent are. Or conversely, if you know what the sine, tangent, and cosine are, you can find out what the number of degrees is. But it's not very sensitive. It only goes to degrees. It doesn't go to tenths of degrees or hundreds of degrees, at least not this table. Okay? So just to show you how this works, in our first example, we said that the ratio of the length of the opposite side to the length of the adjacent side was 20 to 100. In other words, I had the opposite side about 20, and the adjacent side here is about 100. So opposite, adjacent. Okay? And again, the ratio of the opposite to the adjacent side is called the tangent. So if we go and look under tangent and find the values of 0.1944 and 0.2126, as 0.2 is between these two values, I can go down here and see this right there. And since 0.2 is between those two values, the angle that we're talking about must be somewhere between 11 and 12 degrees. So That is, if the ratio of the opposite to the adjacent side is 0.2, the corresponding angle must be somewhere between 11 and 12 degrees. Okay? We also had a right triangle where the ratio was 5/12 or 0.416. Using the same trig table, between what two values must the angle theta be for this ratio? If we go back up here and we find out that the value lies between 0.4040 and 0.4245, we find out that our angle must be between 22 and 23 degrees. Now, there are two ways to view this information. We can either know the angle theta and find out what the ratios are, or we can know what the ratio is and find out what the angle that corresponds to it is. Now, we use calculators now, not trig tables. So if you know the angle is a certain number of degrees, to find either sine, cosine, or tangent on your calculator, simply hit the sine, cosine, or tangent button, and this will print the name of the ratio on the screen and give you a left parentheses. So if I hit the sine button, it'll print sine and then a parentheses on the screen. Then you type in the number of degrees and close the parentheses, and make sure your calculator is set to degrees, not radians, and that will give you the sine. Now, a couple of things about the relationship between the opposite and the hypotenuse, and the opposite and the adjacent, and the opposite and the adjacent and the hypotenuse. A couple of things about these I want you to understand. When you find the sine of a certain angle, make sure you understand that you're finding the ratio of the length of the opposite side of a triangle to the length of the hypotenuse. Okay? I'm finding, so if this is my right triangle, I'm finding the ratio of the length of this side to this side. Okay? And if I look down here at number 1, and if I say that the angle is small, look at the ratio of the opposite to the hypotenuse. It's going to be less than 1/2. This side is going to be less than 1/2 the length of this side. If I moved this over here, I would find out that the length of this opposite side is less than 1/2 of the length of the hypotenuse. Okay, so if my angle is less than 30 degrees, then I'm going to have a sine of less than 1/2. If my length of the opposite side is exactly 1/2 of the length of the hypotenuse, if I swing that up here, okay, if I swing that up here, I'm going to find out that the opposite side is exactly 1/2 the length of the hypotenuse, and my drawing is not quite to scale there. And in that case, my sine will be 1/2. So you should remember this value. The sine of 30 degrees is 1/2. The opposite side is 1/2 the length of the hypotenuse. And then if the opposite side is going to be greater than 1/2 of the hypotenuse, if that ratio is greater than 1/2, my angle will be greater than 30 degrees. Okay, so this is a way that you can help yourself judge what your answers might be, or what they'll be close to being on things like standardized tests. You can help you use this kind of information to check your answers. And for a right triangle, the length of the opposite side can never be greater than the hypotenuse, so the sine is always going to be somewhere between 0 and 1. Okay? That ratio can never be less than 0. It can never be greater than 1. Now, we can do the same thing with the cosine of a certain angle. Make sure you're finding the ratio of the length of the adjacent side. Right? Okay, so I've got the adjacent side compared to the hypotenuse. And this is going to be the opposite of what the sine was. Okay, so if I've got the adjacent side here and I've got an angle greater than 60 degrees, if I've got an angle greater than 60 degrees, the adjacent side will be less than half of the length of the hypotenuse. Okay, you can agree that this is less than half of the adjacent, or half of the hypotenuse, right? So at an angle of 60 degrees, my cosine will be less than 5, or an angle greater than 60 degrees, my cosine will be less than half. If I have an angle of exactly 60 degrees, my adjacent side will be half of the hypotenuse. So at an angle of 60 degrees, this ratio will be 1/2. And then at an angle of less than 60 degrees, my adjacent side will be greater than 1/2. And so I'll have a cosine of greater than 1/2 there. Okay, and again, make sure you understand that for a right triangle, the length of the adjacent side can never be greater than the hypotenuse, so the cosine can never be greater than 1. And then finally, when you find the tangent of a certain angle, make sure you understand you're finding the ratio of the length of the opposite side of a triangle to the length of the adjacent side. If the angle is greater than 45 degrees, the opposite side is automatically going to be longer than the adjacent side, so the tangent will be greater than 1. If the angle is exactly 45 degrees, the opposite side will be exactly the same length as the adjacent side, so the tangent will be 1, or that ratio will be 1. And then if I have an angle less than 45 degrees, the opposite is going to be less than the adjacent side, and so the tangent will be less than 1. Okay? So, what if we're given the ratio? What if we're actually given that value? We're actually given the sine or cosine or tangent, and we want to know the angle. Okay? What if I want to go backwards? That process, I need to go backwards. The process of finding the angle given the ratio is called finding the inverse. So if you're given the sine and want to know what the angle is, you find the inverse of the sine, and we'll see that designated as sine to the -1. That means the inverse of the sine. This is also known as the arcsine. If you're given the cosine and you want to know the angle, you find the inverse of the cosine. That's designated cosine to the -1st. And this is also known as the arc cosine. And if you're given the tangent and want to know the angle, you find the inverse of the tangent, designated tangent to the -1. And this is also known as the arctangent. To accomplish this on your calculator, you hit the second button and then the ratio that you want to use. And on the screen, you'll have the inverse sine or the inverse cosine or the inverse tangent printed. And this will be followed by a left parenthesis. Then you type in the value of the ratio or the ratio itself and close the parentheses. And then the answer will be the number of degrees. So let's do this. Let's test this. In your above example, we said that when the ratio of the opposite side to the adjacent side was 0.2, the corresponding angle was between 11 and 12 degrees, according to the trig table. So find the inverse tangent of 0.2 on your calculator. Hit the second button, hit the tangent, and then add 0.2 and close the parentheses, and you should get 11.30993247, and that confirms what our trig table said, that that angle was somewhere between 11 and 12 degrees. So The relationship between the ratios of the different sides of the right triangle and the corresponding angles is so important. We have a mnemonic to help us remember the names of the ratios and the corresponding sides. This is pronounced SOHCAHTOA. So sine is the opposite over the hypotenuse. That's the so part. Ka is cosine adjacent over hypotenuse. That's the cosine. That's the ka part. And then toa, sine is, or that should be, wow. I screwed that up, didn't I? And I can't change that. So tangent is the opposite over the adjacent. So that's the TOA part. Okay, now I want to make sure that you have a good understanding of how to find values for sine, cosine, and tangent given an angle, and how to find angles given a value for sine, cosine, and tangent. Okay, so using the trig table, and I've given you that, or if you're doing this online, you can go to this website and print up that trig table or just view it online. Given the following angles, which are not exact whole number angles, state the values between which the actual sine, cosine, and tangent must be. Notice that the table headings for values of trig functions between 0 and 45 degrees at the top are at the top of the table, while the table headings for values of the trig functions between 45 degrees and 90 degrees are listed at the bottom. And I've done the first one for you. And I'll end up doing a couple here for you just to make sure that we understand this. Let's actually go to this website so I can print up the whole trig table. So I can go back and forth. So here's that trig table. And so let's now go back to what I want to do. And so, you know, and I think I'll just go ahead in the context of the video for the online people, or if you miss this in class, and just go ahead and do these so that you can do these following along with me. I would rather you stop the video and do these yourself and then check what the values are, so you can do that, but I'm not going to know if you actually do that or not, but I will want you to fill these in. Okay, so if I say that the angle is 17.6, and I go to my trig table, I want you to go down here to between 17 and 18, and I can't draw on the web page here, but I can point out that the value is between 0.294 and 0.3090, and the sine is between 0.9563 and 0.9511, and the tangent is between 0.3057 and 0.3249. Okay, and then I can go back and show you that yes, in fact, those are the values that I put down here, and I rounded them to the nearest thousandth in this case. Okay, so if I want to find the rest of these values, let's just do those real quick. And I'm actually going to grab a trig table. Rather than going back and forth. And so the next angle is 29.2. And actually, I'll go to 20. I'll do this. And so I notice that 29.2 is between 29 and 30. So 0.48, 48, and 5. Point 48, 48, and 0.5, 0, 0, 0. And since I don't want to do the rounding, I'll just do these. And then the cosine 0.8746, 0.8746. And 0.8660. And then for the tangent, 0.5543. And 0.5774. Okay, and notice that's what we would expect for the tangent. We would expect it to be less than 1 since it's less than 45 degrees. For the sine, it's about 1/2, right? Because it's about 30 degrees. That's our dividing line. Less than 30 degrees, and I'm going to be less than 1/2. And cosine is going to be at 30 degrees, 0.8660. If I go to 38.9, so 38.9, here's 38 and here's 39, 0.6157. 0.6157 and 0.6293. Okay, so now that's greater than 1/2, right? Because I'm greater than 30 degrees. I forgot my angle. 38.9. Okay, 0.77 or 0.7880. 0.7880 and 0.7771, and then for tangent 0.7813 and 0.8098, 0.7813. That wasn't right. 0.7813. .8098. So we're getting close to 45 degrees here, so we're getting close to 1 for a value of tangent. And then on the other side of this, an angle is 64.1, okay? And so 64.1 or 61.4, 64.1. Okay, and so my value is on the other side, okay? I've gone over here to the other side, and it's between 64 and 65. And for the sine, I have to go down here and look for that value. So 64.1 is between 0.8988 and 0.9063. So 0.8988 0.8988 and 0.9063. And then for the cosine, here's the value down to the cosine. I got to go up here, and between 0.4384, 0.4384, 0.4384, and 0.4226. And now my tangent should be over 1 now, since it's over 45, since the angle's over 45. And here's the tangent right here for this bottom, for this other side. And you can see it's 0.20503, 2.0503. 2.0503 and 2.1445. Okay, sorry about itching my nose here. Okay, and then I'm going to let you do the last one by yourself. Okay, and then using your calculator, I want you to find the exact values and confirm that those are in fact between those numbers. So 3.302 you can see is between 0.292 and 0.309. 0.953 is between 0.951 and 0.956, and 0.317 is in fact between 0.306 and 0.325. And so I'm just going to let you do those yourself. Okay, so go ahead and do that. And this is going to be all that we do for the rest of this lecture. Okay, so that's the end of that. We'll finish this exercise in the next discussion, and this should be it for this lecture.